We now understand the process of vaporization as the process by which liquid particles go into the gas phase. We also know the key differences between these phases. In the liquid phase, particles are in constant contact, participating in whatever intermolecular forces their structure dictates that they are capable of. In the gas phase, however, they are far apart from one another and essentially not interacting. This means that vaporization will always be an endothermic process, because to go from a state where energy is stored in electrostatic interactions, in other words, a lower potential energy, to a state where energy is not stored in these interactions, or a higher potential energy, the system must absorb energy. In fact, it must absorb precisely the amount of energy stored in those intermolecular contacts. A liquid like water will absorb this energy from its surroundings in the form of heat energy. That's why if you get out of the swimming pool and you're all wet, in order for the water to evaporate, it will absorb heat from your skin, and you will feel cold. The energy associated with the vaporization process is called the enthalpy of vaporization. Here is the enthalpy of vaporization for water at room temperature. We can see that it will take about 40 kilojoules of energy to vaporize 1 mole of liquid water. If vaporization is always endothermic, that means condensation is always exothermic. And when 1 mole of water vapor condenses, it will release this same amount of energy. This makes sense because if the water molecules suddenly begin storing energy in hydrogen bonds, the system will go to a lower energy, and that difference in energy will be released. Our bodies can use this process to keep us cool, which is why we sweat. As the sweat evaporates, it cools the skin. We can lose up to 1.5 liters of sweat per day, and even though sweat isn't pure water, we can get a pretty good approximation of how much energy it takes to evaporate that much sweat, given that at normal body temperature, the heat of vaporization of water is a little over 43 kilojoules per mole. All we have to do is convert this volume of water into a mass, and then into moles, and then multiply by the energy of vaporization. And we can find out that 3,600 kilojoules of heat are removed from your body when this quantity of sweat evaporates. Definitely useful on a hot summer day.